This is a video recording of Chapter 3, Section 2 in the 8th grade textbook, The Instruction for Graphing on the Coordinate Plane. Now we're taking a little detour from the path we've been following through Chapter 7 because what we're about to see in Chapter 7 involves geometry on the coordinate plane. But if we don't know how to work with the coordinate plane or have forgotten how to work with the coordinate plane, we'd be in quite a bit of trouble in the upcoming sections. So we're going back to 3.2, which is all about coordinate plane, and then we'll run back to Chapter 7 to cover the geometry of the coordinate plane. So what is the coordinate plane? The coordinate plane is a plane formed by the intersection of a horizontal number line called the x-axis and a vertical number line called the y-axis. The x-axis is the horizontal axis on the coordinate plane. The x-axis is the horizontal axis on the coordinate plane. Y-axis is the vertical axis on a coordinate plane. Y-axis is the vertical axis on a coordinate plane. Quadrant, the four sections of a coordinate plane separated by the x and y axes. Quadrant, the four sections of a coordinate plane separated by the x and y axes. X-coordinate, the first number in an ordered pair. It tells the distance to move right or left from the origin 0, 0. The first number in an ordered pair, it tells the distance to move right or left from the origin 0, 0. Y-coordinate is the second number in an ordered pair. It tells the distance to move up or down, and that's in relation to the origin. The second number in an ordered pair, it tells the distance to move up or down. And origin is the point where the x and the y-axis intersect on the coordinate plane 0, 0. It's the point where the x and the y-axis intersect on the coordinate plane 0, 0. Okay, so let's go ahead and start off with example 1. In example 1, they're asking us to give the coordinates and the quadrant of each point. So let's start with the easy concept, the quadrants. The quadrants are the four parts of the coordinate plane. The primary one here is quadrant 1, and that's kind of where we're always at when we're making bar graphs and line graphs and things like that. And then the quadrants run counterclockwise. So this corner of the grid is called quadrant 2. This corner down here is quadrant 3. And this quadrant down here is quadrant 4. And we can name any point in those by their quadrant location. Of course, the only thing that's not going to work there is if it's on the x or the y-axis, and that's when we'll say it's on the x or the y-axis. Now, as far as naming points, points are named by their coordinates. The first number in the coordinate pair always comes from the x-axis. So where is the point in relation to the number line that runs left to right across the middle of the coordinate plane? The second coordinate is in relation to the y-axis, where the point is in relation to this line as far as running up and down the coordinate plane. So in the first one, point R, its x-coordinate, as we can see, matches up with 1. Its y-coordinate matches up with 3, so that's 1, 3. And that's in this upper right portion of the grid, so that's quadrant 1. Now point S, as you can see, in relation to the x-axis doesn't move right or left at all. So the first number there, the x-coordinate, again coming from the x-axis, is 0. The second number is in relation to the y-axis, that's why it's called the y-coordinate. Well, as you can see, it's the jump below -2, which would of course be -3. So the y number there is -3, 0, -3. It's on the y-axis, so that's why it says quadrant none there, because it's actually on the line. For point T in relation to the x-axis is here at -2. Again, you can see I'm going up from -2 on the x-axis to reach that. And in terms of y-axis numbers, it's at 2. So it's -2 quadrant, -2, 2 as far as its coordinate pair. And that's in quadrant 2, this upper left corner. And point U is at -3, 0. Well, let's see that. On the x-axis, it's at -3, which is this point right here. And then as far as the y-axis number, well, it doesn't go up or down. It's right at the 0 line there. And that's how we get to -3, 0. Okay, so now what they're going to have us do in example 2 is reverse this entire process. Now they're going to give us the coordinate and ask us to graph the coordinate. So let's go ahead and take a look at that. In the A question there, they're asking us to graph 3, 4. Well, remember, the first number is its representation on the x-axis. So on the x-axis, I'm going to have to go over to 3, and its y-axis number is 4. So on the y-axis, I'm going to find 4. And as far as graphing these, I'm going to pull my fingers together, and they meet right here, which, as you can see on the graph, is point A. Point B is asking me to graph 4, 0. So on the x-axis, I'm going to find 4, and the y-axis, I'm going to find 0, which is, again, right here in the center. And I'm going to pull my fingers to where those meet, together to where they meet, which doesn't move this finger at all, actually. And it's right here on the x-axis. Remember, that first number is always an x, the second number is always a y. It always has to be that way. The x-axis is the one that runs left to right. The y-axis is the one that runs up, down. The C point that they've given us is -4, 4. So on the x-axis, I'm going to find -4. On the y-axis, I'm going to find 4. And again, I'm going to pull my fingers together to where they meet, which is right here. And so that's point C, -4, 4. And then for point D at -1, -3. So that means on the x-axis, I have to locate -1. That would be 1 jump to the left of the origin. And on the y-axis, -3, that's 3 down from the origin. And again, I pull my fingers together where those meet, and that's right here graphed as point D. Now, let's continue on here. In example 3, they're asking us to find the distance between the pair of points. Now, as you can see looking at what's graphed here, the points that are plotted there create horizontal and vertical lines. And that's really all you're going to work with in this section is horizontal and vertical lines. We will, later on in the textbook and later sections, see how we work with lines that run diagonally across the coordinate grid. But for now, we're just going to worry about this. So what you want to do here with this setup, when you're finding the distances between the points, is you want to give the coordinates of each point. So let's go ahead and start off and actually give the coordinates of the different points. So M, and notice here in this grid lines here, this is actually going by 2's. So don't go over 1 jump and say 1. Well, that would actually be wrong because each grid jump represents a distance of 2. So this is over a jump, which is at 2, and up 3 jumps, which would be 6. So that's 2, 6. Point L here, well, that's 2 jumps to the right, so that's 4. Again, the grid markers are going by 2's, the way it's set up. And then we're going to go down a jump, which is actually -2. Point N here, well, point N, I'm going to go over a jump to get to point N, so that's 2. And then I'm going to make 3 full jumps down, which is -6. Again, going by 2's. And point K, well, to get to K, I have to, from the origin, go 1 jump to the left, which is -2. And then I have to go 1 jump down there, which is also -2. Okay, so when you want to find the distances now on the line, the difference of the endpoints, really, what you're going to do is subtract the numbers in the coordinate pairs that are unlike or dislike. So for instance, in the first one here, we're finding the distance between K and L, which is this one that runs across. Well, notice that the y-coordinates are the same. You don't want to touch the y-coordinates. Go for the x-coordinates, the ones that are different, -2 and 4. And you're going to subtract them. Now notice the way they've done this, it doesn't really matter which order you subtract them because they're going to have you take the absolute value. So whether you do 4 minus -2 or -2 minus 4, when you're done, you're going to take the absolute value, which is always going to make that answer be positive because that's what absolute value does. But they did 4 minus -2, which is the same as 4 plus 2, which is 6. The absolute value of 6 is 6. So the distance here is 6 between point K and point L. Remember, we can verify that visually because each jump represents 2. First jump is 2, second jump is 4, last jump is 6. Okay, M and N, we're going to do the same thing. Even though it's a line that runs the other way, you still have a set of coordinates that are different. Notice the x-coordinates are both 2. You don't want to touch those. All right, you want to touch the y-coordinates here, the 6 and the -6. So we're going to subtract. We're going to do 6 minus -6, which is the same as 6 plus 6, which is 12. And since the absolute value of 12 is 12, the distance is 12. The only way you would be subtracting things that are the same is if the coordinates were right on top of each other. But in that case, you shouldn't need to do anything mentally because you know that the distance is going to be 0 if the points are graphed right on top of each other.